Oh, 1 minute 20 seconds. Let's do this. Zero array transformation number 3. Give an integer array nums, length and then 2D array query will query die L to R. Each query die represents the following action on nums. Decrement the value at each index in this range by most 1. The amount by which the value is decremented can be chosen independently for each index. A zero array is an array without its element equal to 0. Return the max number of elements that can be removed from queries such that nums can still be converted to a zero array using the remaining queries. If it's not possible to convert nums to zero query, return -1. So I remember this question. Previously, it was more or less a line sweep, right? A line sweep. So what we want to do now is to know how many to remove, right? The max number of elements that can be removed such that it remains possible to convert it into a zero array. We can do the line sweep again. The line sweep would tell us if the original is possible or not. If the original is not possible, then it is simply not possible. So we can do that. After we do that, we need to know how many to remove. Well, we definitely should remove the things that by a most 1, right? Can we binary search this? I don't know. Well, the most important one is the largest number, right? The largest number is the most important. If by removing stuff such that the largest number is not affected, so we have an access, right? So we do the line sweep, so we know at each position how many more it has, right? So which means how many more you can tolerate when you remove at this position. If we are exactly the same,
that means we cannot remove at this position, because once we remove, we'll drop below. So we stay away from the positions where it does not have but we also need to know how many, like each position, because we look in position by position, right? So a position has a budget, right? Position has a budget. So you go for the largest one, right? You go for the largest one, and you're trying to see if those budget gets exhausted, how will the surrounding behave, right? If the surrounding behave well, then yeah, you got one. Yeah, I don't think so. Basically, the minimum possible. Well, you remove the maximum, which means you want the minimum, right? Remaining elements that cover the entire thing. Yeah, we can know which ones are at which position. We can do that. Yeah, but why would it be useful at each position? You know, I know which ones contribute to me, right? I think you should just remove, but you don't know which one to remove. Because I was thinking, I can remove it, you run it again and see if it works. There are many ways to remove this. Is there something greedy in here? Like we should always keep the range that's largest. I mean, technically yes, because you're using one range to cover more than a smaller one can do, right? we find the largest range. We find the largest range, then what? Or you say, give me the largest range that's cover me. We always look for largest range. So for the first position, okay, we look into the queries. We sort the queries first. Alright? Sort based on the start. And then we looking at the first position and see which one this will be the first non-zero one, right? So we go to the first non-zero one, and from now on we can get a list of things with the largest range, the smallest range, right? Because everybody that we have gone so far, they're all zero, so we don't need to consider them, right? So now you're at the current one. Say I'll use this. Okay, I'll use this, so that can bring you down, and but this whole range is also affecting moving on. But since the left hand side we don't care, so we just for right hand side, right? Plus one, then we have something minus down the line. And so I need to cover the current. So you find the next largest that can cover it. And you do the same thing, until you'll exhaust. Now, here we also have an idea. It should be the reaching the most to the right. Right, it should reach the most to the right. Because the more you reach to the right, the more likely you'll save on these ranges. So for each position, right, you want to find all the ranges, right, all the ranges that cover this current point, and you want to use the one to reach to the right the most. Okay, so I use that, and I'll code it. So reach to the right the most. I'll do the line sweep for that. Right, and then we don't know how many we need. Right, so we count how many we need. once we hit all of them, so the current position is done, then we move on to the next one. Now when we move on to the next one, we have already computed something, right? We have something. So if it's not enough, then we will keep going, right? Keep going. Pick another, right? And but if it's already done, then we don't have to pick anyone. Then we just keep moving, keep moving, keep moving. Find someone that doesn't work, then you will just, you know, add it. Okay, this actually sounds like an algorithm. Right, it sounds like an algorithm, but now what we need to do is how do I find all the ranges for a specific position? Like, give me a position, return all the ranges that can cover this position. Well, all the one that hasn't been used yet. How do I do that? So we only care about the end position, right? We only care about the end. So like 0 to 2. Once you do 0 to 2, you can say, starting with 0, we have an end with 2. Starting with 1, we end with 2. Starting with 2, we end with 2. Right? So for this, I can, from 0 to 2, I can produce something. But there's also the thing is, if you've used it, you cannot use it again. Right? You cannot use it again. So it's like, I don't know. If we can sort queries by their endings, okay? Sort a query by their endings from large to small. That doesn't work. Sorted by start. Sorted by starting point. Okay. And then we're at the first index. Two pointers. So we sort the queries, and so we sort the queries with the start, and at the same start, we'll put the smaller one first. Okay. So we sort that, and we have that as well. Now I have 2 pointers. One is pointing to each position, okay, in nums. So we go nums as this position, and then I go to the queries, right? Go to the queries, and the queries, the first one say yes, we have, right? And actually no. What if we sort based on the end? We sort based on the end, okay? And if the end is the same, we'll put smaller front will go to the front. That's okay. Right? That's okay. So, but anyway, when we have current position, we look into this, and then we see if it includes, right? If it doesn't include, right? If it doesn't include, so we have the smallest end, and then we can have bunch, the smallest end. They're all sorted, right? They're all sorted from small to large, right? The smaller goes to the front. So it'll be like this, this, okay? And then we go this. So we check, right? The first one, if it matches or if it contains, then we want to keep moving on because we want to find the range that includes me and also go to the most to the right. So I keep going. But if I keep going, then we'll hit. So you're saying that we should sort in a different way. Okay, so we sort in a different way. Oh, we sort based on the start. Alright, so we check the first. We have to start to finish, right? So if start to finish is smaller than start, and then this is nothing we can do. If we are within, okay, then I just keep trying the next one. Because as I keep trying, the end just gets bigger and bigger, right? The end is getting bigger and bigger. And as long as the front is attached, right? We're attached to the front. So would it be possible? It actually will be possible that something, it's not guaranteed that the end is getting bigger. The end could get smaller because we're sorting based on the front. That's okay. We keep track of what is the biggest end. We keep track of what is the biggest end. Well, we find all the ends, right? So we go through, so this is the current position, and then we go through, everything that includes. So we go from the front, doesn't go, and go through everyone until we find everything that's included current position. Okay, done. Now we have a list of and that includes the current position. Right, that includes the current position. And we can sort them. Right, we sort them and we go the larger one first. Right, we get the largest one first. And we count how many we need to satisfy the current value. So we need like 2, then we just get 2, right? The largest 2. And then we will update the other thing, right? So we'll update them. So +1 plus 1, so we like say if the current value is 2, so we'll plus 2 for this position, right? And then we'll minus that throughout the position. Right, and then we move on to the next one. And move to the next one, we will, update from the previous. We'll update from the previous. Right, we update from the previous, and we check if the current is good, then we don't have to do anything. Then we move on to the next. And yeah, and if we need to do it again, then we just keep moving the pointer forward, and each one we will do the same thing, right? If it doesn't include, then we just skip. If it does, we'll record. I just go through everything and record everything, and then we will get the largest. Right, 1 or 2. So I think it will take some effort to call this up, and I'm not even sure if it's going to work, but we can try. I'm really not sure if it's going to work. It's like a greedy, right? It's a greedy solution. Oh boy. So I'm gonna try with this greedy solution. It's this 3362. Alright, we'll try this greedy solution. Okay. We sort queries by L, right? Because they call L by L. Then we go through each position, each number, right, in nums. Okay. For a number, we find all the queries that can cover it, can cover the number, right? Can cover the number, and then record their r's. Then we find how many queries do we need to turn number into 0. We pick the ranges. We pick the largest r's to serve the current number. This is the greedy part, because the more to the right a range reaches, the less likely that we need another query, right? So the current number. And we also line sweep it, so that if the selected ranges can already cover a subsequent number, we don't need to add another range. Okay. This is actually will come out as ON, but we'll see. Alright, so we do need, let's get N out. What is N? N is going to be nums.size, right? And now we're gonna do vector int line sweep. We don't call it line sweep, so we can call it cumulative cover. Okay, n plus 1. This is cumulative cover. And then we're gonna sort it. Sort queries. Begin. Queries dot end. Doesn't matter. We just sort it. All right, that's the prep. Now we're all prepared. So what we're gonna do is just go through number one by one. Okay? Go through number one by one with index. Okay, so for int I 0 I smaller than n I plus plus, right? So this is we'll go through the numbers one on one. And we say if nums I is the current number minus cumulative cover I, right? If these two is smaller or equal to 0, then continue, right? So this is a previous queries have already covered current, right? The current number. Well, we already current, so we don't have to add, we don't have to add more, right? So we just, and then also I believe int j, we need j as well, right? So yeah, so if the cover is good, then we just move on. And it will be a point where it's not enough, right? So not enough, then I know how much I need, but that's the secondary. The primary is going to be, we can use a priority queue if you want, you know? I just realized something. I need to sort it in a way that the largest go first. No, I don't think I can do that. So then if I go through everything and I find the one with the largest end, right? To cover me for now. That to cover me for now. The problem is like I cannot just move 2 pointers, because if I have some that's small that I skipped, then move on to the next one. The next one might be able to use it. So I shall directly find the one with the largest reach. Alright, I think I'm gonna stop right now. It's been half an hour. It's not going anywhere. I'm gonna just copy and paste, and then some other time. This is copy and paste. Must do it by yourself. That's all right. I mean, we have done this many times. And we'll do this. Okay, yeah. So I'll come back to this. I'll give it some more time to think about it. I think we're on the right track. We just need to figure out how to get this, how to get it right. And how to easily find the element, the ranges that extend more to the right. There might be a way. There might be a way. Oh, I'll think about this tomorrow.